All right, kiddos, we are actually going to start chapter 1. We skip over 1.1, we go straight to 1.2 because it's going to take a while. So we really want to get to the heart of things that matter here. We're going to talk about functions and their properties, some things that it's going to be a very conceptual section. So we're really going to break it down. Some things that I hope that you are familiar with over the last few years is a map, right? We have our x values of the domain, and we're going to map those over to the range. We just want to make sure we don't need to list them twice. So if anything is in there, we would just relabel our maps. My hope is that you've seen a lot of those. If not, we will talk about that in class. The next one is a table. We're relatively familiar with that and the set of ordered pairs. But I just drew through these from here, and then I put them on the graph just as a set of ordered pairs. We started getting some definitions that since I have a set of ordered pairs, that makes it a relation. And that's no big deal. So everything is a relation. And the big difference is some relations we can define more specifically as a function. So that's what we're going to get into. So we have our definition down here. This would totally be from a textbook. My hope is that you have a clear understanding at this point. Otherwise, the real skinny part of it is we're looking for all different x values. Okay, if we do have any repeats, we want to make sure they repeat the entire ordered pair. Okay, so if I added on 4, 4, that would be a problem because I already have 4, 3. However, if I had another 4, 3, that means I would have this point to the right one more time, and that would still pass the vertical line test. So those are the two kind of little nuances. A lot of kids just go with, well, if none of the x's repeat, then it's okay. If they do repeat, remember that little piece on the end. Textbook definition, like I said, is right here, talking about domain and range. We are usually pretty confident by now about the vertical line test. Remember, it does have to be tested at multiple locations to say that it only hits once and only once. So is it a function? Yes, for this one. Okay, as we look at the second one, we're not going to find anything. So yes, it's a function again. And in the last one, right, if I only tested here, it could look like a function. But remember, I'd have to test the whole way across and have it pass. So this one is not a function. So what could we call it? This is still determined to be a relation because it is a set of ordered pairs. So if we have the graph visually, this is the easiest, fastest way to deal with it. We just want to review those definitions up above, kind of get a little practice with those ordered pairs. So function notation is hidden underneath here now that I scribbled all over it. We use f of x. Remember, that's the same thing as saying y, and is just technically called a function notation. We had thrown some things in front of you talking about domain and range, about using our interval notation, and my hope is that you've also dealt with the union, right? So that means we want to tie some things together. So we know that we have parts of answers and they both count, so we're going to make it into a union. We're going to see that down here in this middle one in just a second. So we're going to use this interval notation and find the domain and the range. So the domain, right? So this is 1, 2, 3. So this is -3, 0. I like to list an ordered pair if there's definitely a starting point for it. So I know that x is going to be compared to -3. And in this case, it's greater than or equal to. So what's that look like in this interval notation? That means I'm going to start at -3. And I'm going to go to infinity. Now, I know infinity gets a parentheses, but my -3, that's going to count. So it can be -3 because that is the actual ordered pair here. So that's going to get a bracket. When we look at the range, why this thing's going up, so it's greater than or equal to that 0 value. What's that look like? Well, we're going to start again at my lowest value, which is 0. I'm going to go to infinity, and I've already filled in my brackets with that. All right, our second graph here, we have a couple things going on, and it's going to cause, I'm going to skip out on using the inequalities because what we have is we have a vertical asymptote. So this is 1, 2, 3, 4, 5. X is 5. Means that that's a number we can't cross over. So if we look at the domain first, looking at our x values, that means this will continue and this will continue. We should keep that below the y-axis for the range when we go to talk about it. And that means I'm going to start at -infinity. I'm going to go the whole way up to 5, but not include it. I'm also going to start at 5, but not include it, and go the whole way up to infinity. So this makes up my domain, but I need both of these parts. So what I want is that U shape in here. I want the union of those two things. So we have it. So for the range, we have the same thing going on. We're going to start at negative infinity. Okay, that would be way down below. That's looking at this section down here. We're going to go up to 0, but not include it. We want the union of that with 0 because we do have this horizontal asymptote in here as well. And that's going to go up until we get to infinity. Okay, so that's how we're going to use the union between those two things. All right, the last one is a quadratic. So domain-wise, it's very tempting that we're just going to say it's all real numbers. But remember, what happens is that's negative infinity until we get to positive infinity. For the range, we're going to start off at 0, and we're going to go to infinity. We know infinity is always going to be parentheses, and here, since 0 is the vertex, keep trying to fix that 0, and it looks terrible each time. Then we're going to use a bracket on that one. All right, so headed down here, this is the symbol, right? It's kind of that double-stroked R for all real numbers. Hopefully you've seen that and you like to use it now. It is a little bit faster. Infinitely many, we'll probably cut that out by now. All reals, if you write it out, that would be fine too. So if we have the graph, you can see this is pretty workable. It's not the worst thing in the world. We can kind of see what's going on. So just doing some re-highlighting. So my domain in yellow, right, left and right forever, all reals. My range in green is only going up from here. So we're getting a one-way direction with that, just like our hallways right now. It gets a little bit more difficult and we have to do a little more processing if we give you the equation. So you have to remember there are a couple things to really look out for. So when I look at the first problem, without reading through all this stuff, I look at the first problem. Can I take the square root of a negative? No. Okay, so that means there's going to be a domain restriction here. Now, can I take it and get an imaginary number? Yes. Okay, so don't get too confused with that. So we want to make sure we're working the real number set here as we identify what's going to happen with the graph. So we have to remember underneath the square root, this part has to be positive. Well, that means it has to be greater than or equal to 0. So that means my domain, as I subtract 2, x has to be greater than or equal to -2, right? Because I take the square root of 0 and that's okay. So when we look at just the domain is now described as -2 included until infinity. All right, not too bad. Right, so you know we're going to have another square root over in h of x, but we'll get there. When I look at fractions, remember we can't divide by a fraction. So what I'm going to do is I'm going to solve this denominator, x equals 6. Well, now I've identified exactly the number the domain cannot be. So before we would have said x cannot be 6. Right? This gets a little more confusing because I need to make it look like a union. Okay? So that means from negative infinity, I'm completely okay until I get to 6. And I have a union, I'm completely okay when I get to 6, right? 6.0001 or whatever it is until I get to infinity. So as long as I don't include the number 6, this is my union. Okay? It was a lot nicer in Algebra 1 when we said not 6, right? That's okay. You'll get used to it. We've got all year. All right, in the next one, we have two things happening. Okay, so we want to try and look at the overlap and see what happens. Now, x cannot be, right? X has to be greater than or equal to 0. It can't be negative. At the same time, if I solve this, I get x cannot be 4. All right, so now we have a couple things that we can do with this. So specifically, it can't be 4, but it has to be greater than or equal to 0. So we need to tie all of this together. So if you were to think about it on the number line, you're thinking that I have 0. I can have everything here, but I also have at 1, 2, 3, 4, I have this missing item. So that means we're going to build another union. So I hope that you're feeling a little better about that. So my domain now, 0 can be 0, right? Let me fill that in. So that means we want this to be a bracket. and we're going to go up to but not include the number 4, union, not include the number 4, and then it continues on to positive infinity. Okay, so this is very conceptual, and you can see why we're going to spend a few days just working through this 2-1 section, because we've seen the graph, and now we're dealing with some of these little pieces and what has to happen, particularly under the square roots, the radicals, and with fractions. All right, our last one here, what's it look like? Well, that's y equals mx plus b, so that's a line, and that means we can use everything we need to. So that means our domain is going to start at negative infinity and go to infinity. And that's just using this last note here, that all real numbers is now translated in notation to be negative infinity to positive infinity. Why do we do that? It just shows a greater understanding of what's happening. All right, we got one more of these. And this one overlaps because right now we don't have any restrictions, right? But as soon as we start talking about a real world situation, this is the area of an equilateral triangle. So we could go through and squaring something, there's never a problem with it. But the domain here is, can you have an equilateral triangle that has the sides with a length of 0? No. So let's first get the idea down. It means it has to be greater than 0. So how do I write that in the notation needed today? Could it be equal to 0? No, I don't know why I put that on there. Okay, it has to be greater than 0. So that means we want to go with 0 not included up to infinity, of course never included for infinities. Okay, so when we look at it, it's fine, right? Because we're squaring it, but because it's being used in this 2-dimensional figure, then we can't use negative signs. All right, last thing we have here, thanks for sticking with me, is the range. Okay, so if we're going to deal with the range, we got to see the graph, right? There's no real shortcut for this one. We want to see the graph. So what it did is it took this one, I threw it in Desmos, and now we're looking for the range, which remember is the y values. So what potential y values are not included in this graph? Well, that's where y is 0. So what we have to do is we're going to throw 0 in here where y is, and we're trying to solve it. So what happens if I try and cross multiply here? I get 0 equals 2, which isn't true. So I'm getting a false statement. So what I find out is that I now have a range restriction, right? Y cannot be 0. So how do we write it? Negative infinity, up to 0, don't include it. Union, 0, don't include it, through infinity. And then we have our range. All right, so very conceptual today and dealing with rewriting things you already know. So it's kind of like a language class today. So thanks for sticking with me, and we want to make sure that we try these problems out. You can check your odds when you finish. I'll have that also in your notebook here, so you can check as you go if you need to. Where's the mouse? Yeah, turn the video off.